attacking that carbon. And again, we sort of know that if we go through a carbocation, I'm going to actually have rearrangement. So just seeing the product here is going to tell me that it's substitution, not elimination. And it's also going to tell me it had to go by SN1 because there's been some rearrangement that's occurred. So let's look at the reaction mechanism here. The first part of the reaction is actually to lose that bromine and form the carbocation. And then I have to have attack by my nucleophile, and it's a weak one here. So I have those electrons move in toward that carbocation here to actually form this new molecule here. Notice here, I still have a hydrogen off here. I still have to keep my positive charge because I have a positive charge here. I have neutral molecule. I still have to keep my positive charge. The easiest thing to do is I need to somehow lose that hydrogen. It turns out, in this case, methanol, it's got a lone pair of electrons. It can actually be attracted toward that hydrogen. The electrons in there will move over to stabilize that positive charge, and I get that molecule right there. So whenever you have an alcohol acting as a nucleophile, you also have to have a second reaction to get rid of that proton, that hydrogen off that molecule. If I had sodium methoxide here, it doesn't have the proton on it. It's a strong nucleophile. I don't have to have this extra step in here. Okay? How do I get to this product? Well, I know I still go through a carbocation, right? So if I lose that bromine, I can go over to that carbocation. I know that that's a secondary carbocation here. I can realize that if I could actually have a hydride shift off of this, there's 3 hydrogens out here. But if I did a hydride shift there, I form a primary carbocation. That's not thermodynamically favorable. But if I do a hydride shift here, I can form a carbocation that's allylic to all those double bonds in there. So that's a favorable reaction. That's thermodynamically favorable. This carbocation is more stable than this carbocation. And then I could go through the same sort of reaction that I went through down here. I have my weak nucleophile react with my carbocation. Then I have my weak base react with my hydrogen to lose that to form that product right there. Notice also I have not defined any stereochemistry. That also is pointing toward an SN1, right? If I had defined stereochemistry, that's pointing toward an SN2 type of reaction. So there's a lot of things just by looking at the reactants, the conditions, and the product here that tell me a lot about what that chemistry is. It tells me SN1, it tells me rearrangement. Okay? Let's look at these. Would you expect if I took this molecule right here and instead I had a chlorine on there, would that be faster or slower? I'm looking at the reaction rates. There's actually a couple pages in your book that talk about leaving groups and what the reaction rates are. Is chlorine a better or worse leaving group? Because I'm going to go by SN1, so it really depends on how good a leaving group is. It turns out it's a poorer leaving group. Bromine is better than chlorine as a leaving group. How about iodine? Okay. Bromine, iodine is actually a much better leaving group. Okay. So in this fact, it's even faster. Okay. How about if I had actually defined stereochemistry here? Is that going to be a faster or slower reaction than the racemic mixture of the other one, right? Don't know the stereochemistry. Just saying, because it doesn't matter. It's an SN1. Once it leaves, I form the carbocation. So it's not faster or slower, okay? SN1s are not stereospecific. I just lose the bromine. Whether it's an S or an R molecule, it doesn't make any difference, okay? How about if I change the solvent to ethanol, okay, instead of methanol? Is that a better solvating solvent or poorer solvating than the small methanol? It turns out methanol is actually a better solvent for SN1 reactions for stabilizing carbocations. So in fact, if I changed it to there, it would slow this whole reaction down because it doesn't stabilize the carbocation as much, okay? Also, because it's not as solvating, and of course I get a different product, right? Because in this case I have ethanol being my nucleophile, and in the other case I had my methanol being my nucleophile. That's all I have. That takes a few more chapters. It's